All right, we're going to be reviewing the uses of the negative sign. A couple of them you've already seen, and then there's going to be one that's not brand new, but just a new way of looking at things. All right, so you have seen a negative times a negative. What is a negative times a negative, by the way? It's a positive. So if I had 3 negatives in a row, it's still negative, wouldn't it? What if I had 4 negatives in a row?
Positive.
And I have 5 negatives in a row?
Negative.
And so what was the general, that was not the general, the rule about that?
Odds are
negative, positives, right?
Yeah.
Okay, negatives are odd and evens are positive. Are you with me? Okay, so this, in this case, for this particular problem, negative 7 equals how much? What is this answer here?
Oh, that's -7.
-7. All right. Now, look at the next one. We have seen, and I thought I got them all, but this is supposed to be a squared. So let me do this real quick.
You distribute like the negative sign?
I'm going to do this really quick. Take him out and put a little squared there. Okay. You distribute the negative sign, I heard Zach say. That is exactly what you're going to do.
There's no number there.
Because there's no number there. Be very careful, gentlemen.
-1 times that.
Yes, you just do a -1 times all that. It looks like, I need you to look at me. It looks like there's a 10 in front of that. And it's the temptation is to distribute the 10, but it is not a 10. It is a -1. The 6x squared comes down. Write a 6x squared on your board. I would suggest that you do it landscape, and because it's going to be big along the edge. I ask you to bring your 6x squared down. We're getting some boards here.
Mom, what did you do with the paint?
I didn't think anybody wanted it, so I took it. I left it at home. I'm sorry. I'll bring it back. All right, so you're going to bring your 6x squared down. Bring your plus 10 down. Gentlemen, are you ready? I want you to distribute that -1 to all of them. Then I want you to combine like terms. On your marks, get set, go. Distribute that -1 to them all. That is a -3x squared, yes.
Where did you get the square?
I accidentally, the squared, you mean like right here?
The 3x squared.
Where did I get it?
Yeah.
This is the original problem like the textbook would just hand to you. And I accidentally didn't make the 2 that I had back there squared on.
Okay.
Does that make sense? When I was typing it, I apologize. All right, so you're going to distribute that -1, and then you're going to combine like terms.
So would you do anything with 6x squared plus 10?
No, just go ahead and bring it right down. Good question.
Done.
Done.
I did it first. Make sure you distribute that negative to everything. I almost started just bringing things down. It changes the sign of everything. Please check if you have what I have on your first step. Tell me if I've done anything wrong. Did I do something wrong on my first step? Ben thinks I did it right. Did I do it right?
Is that your final answer?
That's not my final answer. That was my first step. I believe those are my only like terms are in blue. Or should be in red. So then I'm going to do -8x cubed plus 9x squared minus 7x. Oh, no, I'm wrong.
Wait.
These ones are like terms.
Wait, which ones?
Then plus 19, I believe.
Yeah, I have -8x cubed plus 9x minus 7x plus 19.
I believe that's my answer right there. But I don't know. I need you guys to make sure I didn't do anything wrong.
Yeah.
That's what I got. Is that what you got? All right, so these are decently review. The next slide we're going to do is going to be some review, but a new way of looking at something that you probably didn't notice in the past. I need you to look up here. A different way, equal, but they look different. If I have -5 plus x, I want you to notice that that is equal to x minus 5.
Yeah.
Why is that true?
Because it's commutative for addition.
Because it's commutative for addition. So I can turn these two around.
You can add negatives.
I can add, right? I can pick my x first and my negative 5 last. And notice it's the same if I switch it around. Are you with me so far? Those are the same, but they look different. They're equal, but they look different. I'm going to show you two things. I'm going to put it in a fraction. They're not quite equal, but they're kind of close. And we're going to do something with them to reduce them. Their signs will be opposite. One will be negative while the other one's positive. Are you with me, Zach, JD? Are you with me? All right. So they're going to be close, and we're going to do something to fix them, to simplify them. I want you to notice the first one. The numerator and the denominator are not equal, but their signs are switched. They have the same variables and the same numbers, but their signs are switched. And so we're going to do something to simplify them.
5 minus 6.
I am going to divide this top one, back up,
Okay.
the top one by a negative 1, or I'm going to factor out the greatest common factor of a negative 1. Are you with me so far? All right, so negative 1 times what equals negative x?
X.
I heard just x. Let's try that one more time. I'm going to ask the question again. Negative 1 times what did I put there will equal negative x?
Just X.
Just x. All right, are you with me? Negative 1 times what that I'm going to put there equals a positive 5.
Negative 5.
A negative 5.
Equal negative 1.
Are you guys with me? I factored out, or I did the backwards distributed property, and now I'm going to put this on the bottom. We did this factoring last week. X minus 5. You were told that you could only cancel what? What are you only allowed to cancel? Factors. You cannot cancel sums, only factors. So we are now going to cancel something out. What can I cancel out?
X minus 5.
The x minus 5 and the x minus 5. I will be left with how much?
1.
The negative 1. So, how in the world did I even know that this was possible? So this is, when you're moving forward in your math, the way that you know it's possible is if it looks almost equal except the signs are opposite. Notice here, I have a negative x and an x. I have a negative 5 and a 5. They're opposites, but everything else is the same. You can factor out a negative, and you'll be able to cancel then. Are you with me? Let's do this again. Is this one that I have over here on the side, I'm going to actually take everything out.
Do you want to distribute first? Would that help?
I don't think so, because notice this. Are these like the other one where everything's the same except it's opposite?
No.
Sometimes it's
I heard no.
multiplication. They get different things.
Let's look at this really quick. Look up front. Over here, I had an x and a negative x, and a 5 and a negative 5. Everything was the same except it's opposite. Is that true for this one? At least this part?
I don't think so.
No, that part is.
It is or it isn't? Because we have some people who say no, some people saying yes.
Yeah.
Yes, it is.
Yeah.
But not on that side.
Well, let's figure out my x. I have an x and a negative x, do I not?
Yeah.
And I have a 3 and a negative 3, do I not?
Yeah.
What if I flipped?
But
Go ahead.
you said, did you say a negative 3 and a negative 3?
I meant to say, if I did, I apologize. I meant to say a negative 3 and a 3. I apologize, man.
Actually, those aren't opposite.
Are they?
It's minus.
What if I flip this
Because
around?
if it's 3 minus 1, then it'd be 1 minus 3.
Yeah, that's what I was.
What if I flip this one around? What would it look like?
Negative x plus 3.
It would be a 3. This x would go in front, right? Negative x. And the 3 would go in back. And what would be in front? What would be the symbol in front in the middle?
Plus.
It would be a plus.
But you could do it 3 minus x too, right?
I could have flipped that one around if I wanted, yes. Yeah, I could have. Can you see how these are like the yellow one over here?
Wait.
This yellow one over here, they're very similar. I just didn't cancel this. Okay. Can I cancel anything right now?
No.
No, I can't cancel it right now. Okay, so but you were told that if everything is the same but it's just the opposite signs, I can factor something out. What can I factor out? All right, you want to factor, we said we're going to factor out a -1, correct? He says he wants to do the top, and I'm fine with that. I'm going to put it in front of the 2 because the negative usually we multiply. All right, so the negative here times what gives me x?
Wait, the 2 times x? Is that what you mean?
Be careful. I apologize. Let's do it this way. I'm going to do it. I want the 2, and I'm going to factor out a -1. Let's do it that way. Maybe that will be easier to understand. Okay? The -1 times what gives me x?
Just negative x.
Negative x. Very good. Negative x. Are you gentlemen with me?
So you just assume that there's a 1 right there?
No, I'm actually doing, you know how we did the greatest common factor? There is a negative that I can take out of both of those in this yellow thing right here. There is a negative I can take out. So I am taking out a negative. And I did that because these are the opposites. And if the opposites, I'm going to try to cancel. Okay? All right. -1 times what gives me -3? Anybody?
Negative.
3.
3 or -3? Which is it?
3.
So let's just see. If I have a +3 and I multiply by -1, does that make a -3?
Yes.
Yes, I need everyone to make sure that they're paying attention and drawing, either writing what I'm writing or just watching. All right. I have a 3, -x plus 3. Can I cancel now?
Oh, wait, you can't.
I can?
Yeah.
Where?
-x plus 3.
-x minus plus 3. That's right here. It's these right here. And now I'm left with a 2, a -1, and a 3.
-2. It's a -2 because you.
Oh, it's a -2 now?
Because you're multiplying by -1, right?
Yes, because I multiply. That's going to be -2
2/3.
over 3. Okay. This is the new stuff. I think the reason that this one is hard is not because the math is hard. It's because you don't look at those and think they look like they're equal. When you look at these two right here, they look like we're done. You can't cancel anything, but I want you to be cautious. If they have the same letter and number, but they're the opposite signs, you can reduce it by factoring out a -1. I want you to do number 1, 3, and 9. Number 1, 3, and 9. All right, let's do number 1. I got 4 negatives. 1, 2, 3, 4. So it turns out to be
4, yeah.
just 4.
Positive 4.
Positive 4. Be very careful. This 9 is not what you're distributing. You are distributing the negative. So we will have 5x to the third plus 9 plus x cubed minus 2x squared. Can I do anything with those?
Cubes.
The cubes. I'm going to keep it red so you can see it. That's going to be 6. 6x cubed minus 2x squared plus 9. I tend to put it in descending order of exponents, but it's not. Doesn't have to be in that order. Are there questions about those? This is the one that might have been stumping people. All right. We have a 1 in both of them. Do you see that? We have an x squared in both of them, but they're both of the signs are opposite.
Take the -1 out of the top one.
You want to take the negative out of the top one. This is the part that's getting people a little stumped. Since they have the same numbers and the same variables, but everything's the opposite, that means we can take a -1 out. -1 times what gives us +1? -1. -1 times what gives me -x squared?
Positive.
Plus x squared.
Is that a plus or a times?
I'm going to have to fix it again. I will give me more room. I will make it bigger. Plus, is that better? Is that better?
Yeah.
Okay, now, over x squared minus 1. Can I cancel anything right now?
Yeah. Well, I mean, it's the same thing. It's just rearranged. X squared minus 1 same thing as negative.
Ashton, do those look the same, the top and the bottom? Are these two the same? Yes, that's correct.
They just look the same.
They are the same. Do you understand how we can cancel them? This one right
They
here
are, 'cause it's a-
Yeah, they're
with
the
this
same.
one right here. Can I reduce those out?
Yeah.
Yes,
just
Yes,
get rid
you
of
can.
both of
And
those.
I'm left with just what?
Negative.
-1. All right. The way you know that you can do that is you have all the numbers and all the variables are the exact same thing. Well, not exactly. Are the same, except you have their opposite signs on everything. We have now reviewed and expanded your factoring and canceling with negatives, with negative expressions. We're finished.